In this video, we're going to look at the volume of a pyramid. Now here we have a little definition of a pyramid. We have a pyramid is a three-dimensional geometric shape with a polygon base and triangular sides that meet at a point called the apex. So here I have a little diagram of a pyramid. So this here would be the polygon base. And in this pyramid, I have a rectangle here for the base. Now a polygon is a closed shape that consists of three or more sides. So a triangle is a polygon, a square is a polygon, a rectangle is a polygon. We could even have a hexagon, a heptagon, decagon, all those are polygons. So the base could be any polygon. And the sides would be triangles. So here you could see the triangular sides and it meeting at a point. So that's the thing about a pyramid. What makes the difference between a pyramid and a prism is that the pyramid, the triangular sides here meet at a point called the apex. Whereas a prism, you will have the base at the bottom, and on the opposite end, you'll have the same shape, just like the base. So now here I have this distance here, and I'm calling that distance h. And you can see it's at 90 degrees to the base, and it goes all the way up to touch the apex. So h is going to be the height of the pyramid. That's the perpendicular distance from the base to the apex. And I have that little definition here. So h being the height is the perpendicular distance from the base to the apex. So I'm going to write volume of pyramid is equal to 1/3 multiplied by the area of the base multiplied by the height. So this would be a general formula for any pyramid, because the only thing we'll be changing with the pyramid is the shape of the base. So once you know how to find the area of the base, you multiply it by 1/3 and also by the height of the pyramid, the perpendicular distance from the base to the apex. Okay, so here I have a pyramid where I put in the dimensions of the sides. So we have this side is 12 centimeters, this side is 7 centimeters. So this would be a rectangular base pyramid. Here we have the height of the pyramid would be 10 centimeters. So now what you can do is we call the area of the base. All right, so area of rectangle. And remember the rectangle is the base. Will be equal to length by breadth or length by width. The length will be 12 by 7, so that's 84 centimeters squared. So now the volume of the pyramid is equal to 1/3 by the area of the base times the height. So that'll be 1/3 times 84, because the area of the base is the area of the rectangle. And of course, your height is this 10 centimeters here. So that'll be equal to. Now you could cancel, you could put the 84 over 1 and the 10 over 1 and see what you could cancel. Or we could use the calculator and just type all this in and get the answer. So on the calculator, we put in the 1/3, use the fraction button, 1/3. And then we multiply it by the 84 and then by the 10. And we get 280. Instead of using the fraction button, we could use the divide sign. We could have put 1 divided by 3. And you could go one time and put multiply by 84, multiply by 10. I can see you guys same answer, 280. Now we could also say, if we had put the 1/3 multiplied by 84 over 1 multiplied by 10 over 1, we could also say 1 by 84 by 10. So that'll just be 84 by 10 over 3 by 1 by 1. So that's just 3. And on the calculator, I multiply 84 by 10 and then divide by 3. So on the calculator, I multiply 84 by 10, get the answer, and then divide by 3. And I get 280. So my answer will be 280 centimeters cubed. So while we're on the topic of pyramids, I want to look at the cone. Now, the cone is not a pyramid because a circle is not a polygon base. Okay, you can see the base here of the cone is a circle. All right, but we do have an apex. We don't have triangular sides, however, and that is why this would not fit the definition of a pyramid, because we don't have a polygon base and we don't have triangular sides. But when it comes to the volume of the cone, it follows the same principle as the volume of a pyramid. Because we have this perpendicular distance from the base to the apex, which will be height of the cone, and we can work out the area of the circle, which is the base, the volume of the cone would be 1/3 multiplied by the area of the base multiplied by the height. So the volume of the cone is still 1/3 multiplied by the area of the base multiplied by height. And of course, this area of the base is the area of the circle. And we know the area of a circle is pi r squared, pi by the radius squared. And that's this distance here from the center to the circumference is the radius. This r is the radius. So we have 1/3 by pi r squared, which is the area of the circle, multiplied by, I put h for height. So we get 1/3 pi r squared h. And this is your formula for the volume of a cone. But as you can see, it follows the same principle as the volume of a pyramid. All right, so here we have a cone. We have the dimensions. We have the radius as 3 and the height of the cone as 5 centimeters. So I can work out the area of the base. So the area of the circle, is pi r squared. And we use pi as 22/7. Multiplied by the radius squared, which is the 3. So that's 3 squared. And again, we can use our calculator for this. Yes, you could put, 22/7 multiplied by 3 squared over 1. And 3 squared is 9 and try and cancel. Or we can just run this straight on the calculator. All right, so we can put in, 22/7, use the fraction button over 7, multiply by 3 and press the x squared button to square it. And press equal, and that's 28 and 2/7. So we can write 28 and 2/7 centimeters squared. So that's the area of the circle, which is the area of the base. Now I just want to show alternatively, you have the 22/7 multiplied by 3 squared. You can write that as, 22/7 multiplied by 3 squared over 1. Which some people write as, 22/7 by 3/1 by 3/1 like that. And then you try to cancel. Of course, 3 and 7, cannot cancel. So you'll multiply 22 by 3 by 3 and then put it over 7 by 1 by 1. So that's 22 by 3 is 66 and then 66 by 3. Again, we can do that on the calculator. All right, so 22 by 3 by 3. And we get 198. So we write that 198 here, and 7 by 1 by 1 is just 7. So then that's 198/7 centimeters squared. And of course, if you convert this to a mixed number, you will get the 28 and 2/7. So now the volume of the cone is equal to 1/3 times the area of the base times the height. So that's 1/3 times the 28 and 2/7 multiplied by the height, which is the 5 centimeters. Again, this could be done on the calculator. And if you're going to cancel, you're going to convert this mixed number back into an improper fraction, which is the 198/7. So that's 1/3 multiplied by 198/7 multiplied by 5/1. Okay, and if you were to cancel, 3 could go into 198 66 times. So, this could cancel. The 5 and 7, those can't cancel. So you'll end up with 66/7 multiplied by 5. Or we could just run this whole thing on the calculator. But first, let's cancel. So I just want to show you if you divide the 198 with the 3, you can see that again, 66. So if I were to cancel, I put 3 into 3, 1, and 3 into 198, 66. And that's the only thing that will cancel. So now the question becomes, 66 over 7 multiplied by 5 over 1, which is basically multiplying 66 by 5 and dividing by 7. By equal sign here. So we multiply this 66 by 5, press equal, get 330, and divide it by 7. And we get 41.1428 like that. If you want to convert it to a fraction, just press second function, fraction button, and we get 330 over 7. And to convert this into a mixed number, we just press the fraction button, back to the decimal, and here we have the mixed number, 47 and 1/7. So that's 47 and 1/7 centimeters cubed. Now, I'd just like to show on the calculator how to do this entire thing straight as is. All right, so we are 1/3, so we put 1 over 3. So I use the fraction button there. Multiply by, now I want to put in a mixed number, 28 and 2/7. So you put 28, fraction button, 2, fraction button, 7. So that's the way to do it on the sharp. And that'll be 28 and 2/7. And then we multiply by 5. And you can see we get the 47 and 1/7 one time. So this would bring us to the end of this video, and I hope you understand the concept of a pyramid and finding the volume of any pyramid.